Look. So you have been going on a roller coaster, then obviously not to worry that you get again another peak, right? Okay. Yeah. That's how roller coaster goes on, right? So then your next term exam also coming. Yeah. Yeah. Next term exam also. Okay. Huh? By the end of this month. Yeah. Huh? During holidays? Yeah. During the holidays? Huh? You're going out to country, I'm also coming. You're not taking me? Huh? Now come on, right? So let's first of all let me ask, right? So far we have done logic gates and we have almost completed. We were in the last exercises, right? We were in the last exercises. Akmita, Nikini, can hear me well?
Yes, sir.
Right. So before starting a new lesson today, right? Okay. So that is why I gave all the exercises to complete. And remember, I will do a revision paper most probably next week, right? To cover up the lessons, and that will be more or less equivalent to the next term paper, right? But this time, remember the majority, the majority of the weight for the paper is from logic gates, right? Out of the logic gates, keep remember, I am giving more priority to the problem solving. The last chapter of the logic gates. Okay, right? So I believe everyone done somehow, right? I need your, doesn't matter things go wrong, but I need your effort. You have to put your maximum effort. You understand? Yeah. Okay. I have two books. Okay. I have two books. One is for theory, one is for the revision and questions. Yes, Dad.
I was the one who gave you
Probably you have to put it in another book, right? But for the time being, okay, let it be there. I will check it, right? Okay.
You said normal book, right?
I will check it.
Right.
Okay.
Book, look at.
Why I said like that today? Because like I need to check, right? If I collect those books, you don't have the book in your hand for when you are coming to the next class. And the other thing is now it is high time for you all to remind, or as usually I did it for the Form 4 students, very especially, right? So for you all also, I need to, it is not reminding, it is like, how do I say, alarm, right? It is like it's an alarm, that is, right? We have countable number of classes before the exam, okay? So we have to put your maximum effort, right? So I give my maximum, you have to do your maximum, right? Repeatedly what I am telling you is, right? Don't just go home and keep the book close, right? Now you are getting into Form 4, right? For the exam, there's 1 and 3 months, 1 year and 3 months, right? That 1 year, 3 months mean almost how many days we have? Is it 365 days for the exam? We have last days.
Out of the
60 class days. 60. For the next year, 48 days. That is 4 days per month, right? And your exams are on 27 April. Understood? Next year is 26th. Okay? Days are flying, remember? Right? Time is flying. And right, and the other thing is, right? one thing is, know for sure, right? Cambridge exams are, you can pass through this Cambridge exam. But only the thing is, follow them properly and manage your time. Right? I don't ask you to pay total time on the studies. No, it has to be a blend of it. But we have to enjoy your life, right? That is also have to be a part of it. But always you have to keep in your mind what is the main, the target is over, right? So now before getting into the lesson, right? Because today I'm going to start a new lesson, right? Data. Let's recap some from what we have done from logic gates. Okay. So we started with logic gates. I want to hear from Nikini Akmita, right? Please answer. Right. What are the three basic logic gates? What are the three basic logic gates?
And over.
Yeah. What is the first one? And O, not gate. AND gate, O gate, no gate. So what are the combinational logic gates? Define what are the combinational logic gates in your words. Define what are the combinational logic gates.
Two gates.
Two gate. Repeat. Two gates. Okay. Bringing two more than one gate, bringing together, right? It is not necessarily two gates. Understood? You bring more than one gates, combine more than one gate, and you make another gate. So that is called combinational logic. In this combinational logic gates, what are the main two basic logic gates? NAND gate,
No gate.
NOR gate, N-O, right? N-O-R, NOR gate, right? So what makes NAND gate? Not an AND gate. NOR gate, no and O gate. So what is the exceptional combinational logic gate there we learned? Yes, yes.
XOR gate.
XO gate. Great. XO gate. Right? So what how the symbol looks like the XO gate? Yes? O gate. And there is another parallel line. So this is an XO gate. Okay? Right. Representing this logic gates, right? In the combinational logic gates, when you get logic gates, AND gate, right? How many minimum inputs for there? How many minimum inputs need to have for the AND gate? Yes? Louder. Louder. Confidently. Two. Right? Minimum, two inputs. Right? Maximum? Maximum, two. It can go for any.
Million. Unlimited.
Understood? But mainly there are two inputs, right? If two inputs are denoted as A, right, and B, this and can be represented in Boolean expression by what symbol?
Multiplication.
Dot.
Dot.
A dot B. This A dot B, right? If you represent is as a mathematical operation, what is the mathematical operator that we use for this?
Multiplication.
It is multiplication.
I told.
Right? Apita, Nikini, okay? Okay?
Yes.
Right. Then the next one is O gate. A, O, B. Right? O can be represented by, very good, A plus B. So what is the mathematical representation of this? Addition. Right? Addition. Right? All these values are represented by what number system? Kevin? What is the number system that we use to represent Yeah. Number system. Yes. Binary. Make it louder. Binary. Right? So binary means 0 and 1. Great. Though you said you have forgotten, but you have not forgotten. Great. Good. Isn't it, Stephanie? Yeah. Right. Okay. Right. Once we derive to the combination logic gate, we know if it is an AND A dot B, you use the AND dot to represent AND gate. The plus sign is used to represent the OR gate. Right? A and B, these are two inputs. When we are writing a Boolean expression, right? Each input is considered as a positive, correct, one, or the positive value. Correct, right? The positive means the 0 also positive. Each input, A and B are input to the circuit, right? These are considered always as 1. You're correct. 1. Right? When we are writing a Boolean expression, right? Always we have to write the Boolean expression in a way that represent 1. In a way that represent 1. Am I clear? Are you clear? Yes. Right? So my question is for you, okay? Right? Right. Okay. Right. When A equal 0, when A equals 0, okay? How to represent this as a Boolean expression, right? You are not,
Ah,
right?
I thought that was general question.
Huh?
I think that was a general question.
Right? How to represent this A as a Boolean expression in a Boolean expression? Yes. A A bar. Before that, we write A, before writing this A bar, right? In wordings, how you write it, Stephanie? Not A.
Yes.
Not A. Not A. Right? When you write this word not A, this is what we represent in the diagram. Right? So I use A, this become not A, therefore I can write it as A bar. Right? Whenever the A becomes 0, this becomes 1. So that is clear. Right? When we are deriving to a Boolean expression, right? The Boolean expression, in other words, we write an algebraic expression, but we give a due respect to it with the name of the Boolean, the person who, right, found this method. So that is why we call it Boolean expression. This Boolean expression, when we are writing, we write it for solve a problem. Okay, solve a problem. Then when we are writing the Boolean expression, okay, we have to write the truth table to show the to show how this problem is solving. Okay, so we can write the Boolean expression in 2 different ways. Right? I'm summarizing. Okay, I'm summarizing. One is we have been given some combinations of switches. Understand? 1 or 0 means it is a switch. The switch has either switch on or switch off. Is it Teshana? Yes. Okay. So then if I have 2 inputs called, right? If I have, let's say, 3 inputs, A, B, C. Okay. How many inputs are there? 3 inputs. If there are three inputs, right? If I suppose to write the combination, right, of truth table, how many combinations are there? How many combinations are there?
8 combinations.
Okay. The answer is correct. How to determine that 8 combination? 2 to the power?
Three.
Okay. When there are a number of inputs, 1, 2, 3, I have 3 inputs. You put it into the 2 to the power 3. Right? 3 represents number of inputs. Okay? Then 2 to the power 3 is 8. Therefore, I should get 8 combinations. 8 combinations. Right? If we are being asked to, right, write a truth table, if you have been given, if you have been asked to write a truth table for a given expression, okay, given expression, right? First of all, we have to write down the all possible combinations. Am I clear? Right? If a logic gate works, this is alarm say X, X is equal, right? A dot B plus B bar plus C, right? That is expression. Okay? Why you got? No? Yes? This is just I know. Okay? You can write anything using these 3 combinations. You understand? This is a kind of equation just I wrote, right? Don't be scared, right? Even at the exam, you are being given, don't be scared. It is just an expression given. Understood? But when you are being given this expression, this is how the exam paper gives you, right? But exam paper always helps you much more because this table also been given without this ABC. But the expression is given. When you see the expression, what is the step 1 that you have to do?
The inputs.
Yeah?
Find the
Find the inputs. So what are the inputs there? I have A, B, C. This is what we have to find. Okay. So when we have asked to do the truth table, right? Then we have to write A, B, C. Okay. A, B, C. Then what do we have to do? First of all, we have to write the combination, all possible combinations. And we have to make sure that there should be 8 combinations, right? Then we have to start from left to right. Okay, you start from 0. Okay, 0, 0. You start from 0. Nice. You start from 0. Whatever. Right? 0. Then you go for the next one. 0, 0. What is the next possible? 1. Right? Then 0, 1,
0.
0. 0,
1.
1, 1. Okay. Natalie, what really means this? Am I just writing numbers or of a pattern? Stephanie? This is what you have to understand. Yeah. What really means this? You can tell anything, any story you can tell on this. Here, what do you think?
Say with X or no?
Say whether it is or no of. Correct. Any other thoughts?
Yeah.
Okay. Okay.
Yeah,
What pattern? Can you say, can you tell me a pattern? Doesn't matter things go on. Don't worry, right? Open your mind. Open your mind, right? Yeah? Yes? Anything? Nikini? Yeah?
Let's do it.
Okay.
Yeah?
That side one is going it's changing 1 by 1.
Hmm.
Here one, other one is changing 2 by 2, other one is changing 2 by 2.
Okay. So you have given different explanations, nothing wrong. Okay. So this is my explanation. Understood? This is my explanation. Right? I have 3 switches. Now imagine these are 3 switches. What do you mean by switches? The simple as that. Or no switches. That is what I'm referring, right? Okay, on off switches. Okay. I have 3 switches. I am trying. I'm going to keep everything switch off. It is one state. I'm going to say, okay, like I should have a pattern to do that, to see what the outcome. You understand? If I just keep on switching on like arbitrary here and there, I can't find out a proper answer. You understand? So I should have a pattern of it. So what I should do? So I'm going to keep first 2 switch off, and earlier I made it switch off. Now I'm going to make it switch on and see what's switch on. Okay. So both possible combinations I have done. Understood? While keeping these 2 switches off, right? I have no more options to do in the first one. You got it? I have no more. Right. Then what I can do? I go for the next possible. So while leaving this one, I'm going to make this switch on. And again, I'm trying. What is happening? This one is switch off. This one again switch off. While the second one is keep on. Understood? So this is what we are looking at. What is happening? So far, these are not numbers. These are not mathematics, right? These are logics, or these are something that we try to observe what is happening. Understood? Inquisitive. Okay? Right. But I do it in a methodically. Got it? Now I have tested all this combination. So I have no more further options, right? Then I go for the next one. Okay. I'm going to make this. I have tried making it switch off. I'm trying it, make it 1. Okay. Okay. I made this switch on. Again, I have test it. So I'm going to keep this 1 0, switch off, make it switch off. Okay, with this one, right? 0, 1, 1, 1, 0, 1, 1, 1. Now understood? Understood, right? Don't take it as like numbers like mathematics. If you think like that, you're failing logics. Think in a logical way. So far clear. So these are all possible combinations that I can meddle with switches. There's no more options that I can go for with these 3 switches. That is what it means. Okay. So that is why it says there are number of combinations, means I have 8 combinations. Clear? Right. Now what are we going to do is, right? I have been given these 2, right? When these switches reaches these 2, only this alarm getting on. You understand? So these are the possible options that I can get from these 3 inputs, Natalie. Okay. Right. So then I have A, B, C. Now I have to look at step by step, block by block. I am going to make A dot B. What is that? A dot B mean A and B. Over here, these are just inputs. Now I'm going to put it into logic gates. First one is a AND gate. So A and B. Okay, 0, 0, 0, 0. Stephanie? 0, 0. Louder. 0, 1. Louder. 0, 0, 1. 1, 0. 1, 0. 1, 1. 1, 1. Got it? Now I have, right, B plus C. Okay, great. It is something like we are solving a mathematical equation. What we do first? Solve brackets. Got it? Solve brackets. Right? So for the easiness of doing this, I usually, right, write it as, right, I'm going to name this as, let's say, this is Y and this is Z. The whole thing, output of A dot B is Y. I can write for the easiness. So this is right. I can say Y. Then I need to write B plus C. What is B plus C? It is an O gate addition. Okay. B plus C. 0 plus 0. Louder. 0 plus 1.
B bar.
Ah. B. B bar. Now what I have to do? Not B. So there is another one more step that you have to go before adding.
You have to find the B bar.
Right? Can you do it? So make it B bar. So B is 0. You need to have B bar. Then what will happen if it is 0? The B bar is 1 plus. Is it difficult? Is it difficult? Should I break it? Should I? Yes. If you find difficult, you can break it. First of all, find B bar. So 0, what is B bar? Make it fast. 1, 0, louder. 1, 0, 1, 0, 0, 0, 1, 1, right. Now let's put it B bar dot C. Okay?
So the last one,
Which one last? Which last one?
0 plus like 1.
Which one?
Last.
Which one? This
last,
one?
Yeah.
Yeah.
B bar is 0. 0 plus 1 is 1.
Why didn't that still have finding B bar?
Ah, okay.
Okay?
Yes, sir.
Okay? Okay? Right. Now let's clear B bar and C. B bar, when you say you have to look at this and this. So B bar and C, 1 plus 0. Loud, I can't hear. I have a ear problem. One ear is locked.
One.
Great. 1 plus 1. 0, 0. 1, 0, Yana. I did it. Ah, great. I love that. 0 plus 1. 1, 1. 0, 0. 1, 0. Right. Finally, what do we have to do? Finally, what do we have to do? Right. Now we have to solve this part. That is Y plus Z. Is it understood? Rather than writing the entire expression, I am representing A dot B is as Y, B bar plus C represented by Z. So I can write it in simple form, that is Y plus Z. Am I clear? So Y plus Z means which part I have to look at these two columns. Right? 0 plus 1. 0 plus 1. 0, 0. 0 plus 1. 0 plus 1. 0 plus 1. 1 plus 0. 1 plus 0. 1. 1 plus 1. Okay. So according to this expression of the Boolean expression, this expression is given as a problem, the solution for a problem, right? If X is an alarm, right? This alarm does not fire, okay? Does not fire when ABC on which states? My question is clear?
That's
The alarm doesn't ring or doesn't fire, right? On what condition of ABC?
when B is on and A and B is on.
Right. One mean what?
It is alarming.
On. It is on. So alarm doesn't on mean what is the state that you have to find out from this final result? This is the final result. And this is where the alarm doesn't on. This alarm doesn't on when this combination meets. When A is 0, B is 1, C is 0. Understood? Okay? Quick revision, right? So easy, right? Natalie, okay?
Yes.
Yes? Right.
Sir, camera off.
Right, look at this board. A, B, C.
You're giving so
Okay?
less concerned to animals and I don't.
Okay? Right. So this is the truth table, right? Now the first part I did understood, right? And quick revision I'm doing, right? These are the three inputs. And X is the out. Right. Right? I am asking you to, right, draw the Boolean expression of this. Boolean expression of this. Who's going to volunteer?
Master DNP.
Yeah. Okay. What is the first step that I have to do? Kevin?
Yeah.
What is the first step that I have to do? I have been given. What is this? Right? It has given three inputs. How the switches are, how many switches are there? And you have been given, right, the output. Right? This circuit, if you made this circuit, then the circuit gets on. Right? And when the circuit gets switched off. Am I clear, Aviana? Yeah? Okay. Would like, okay? Volunteer? Right? What is the first step that you have to do to derive, write it? Yeah, before writing the Boolean expression. Question is, you have to write the Boolean expression of this logic circuit. Now, this is a logic circuit, input and output being given. You have been asked to write the, remember, this is how your exam paper, right? Okay. Nothing difficult. What are the things that you have to remember? The rules that you have to follow. That's all. If you remember the rules, that's all, right? Wait. What should I identify first to determine the Boolean expression? If you think of what we have done the previous exercise, previous example, how this alarm, right? How this alarm, the previous example, right? When was that alarm switched on?
When it was one.
When it was
One.
great. Now apply that understanding to this.
Identify all the one.
Identify all the ones.
Simple as that. Open the book out.
If the X is the output, if that is the alarm gets on only when these are getting on. Okay? Done? So then these are the combinations that this logic circuit is working. Okay? Is working. Now, simply read the inputs. Okay? There are three inputs that makes one. What is that? 0, 0, 0. These switches become 0, 0, 0 along getting on. Now represent the 0, 0, 0 using A, B, C. That's all. Using A, B, C. How can I write first one? Yes, Natalie? Before starting, I explain the rule. You told. Always when you are writing a Boolean expression, you have to follow, you have to consider that one. Right? If that is not one, then you have to you have to say not one. Okay. Means using that, right? This 0 means Not A. Great. Right? Not A. What is the logic gate when you
And.
come? And so B, not B. Not B. And simple as that. What's right? Right? Nothing, there's nothing hard to remember. That's all, right? Okay? Okay? Yes? You're going to bless me? Great. Love this.
So you're doing Nazis.
Nazis. Huh?
No, I don't know.
Okay. Then Nazi tell me,
Sir, I'll tell you what.
Nasi Quran. Don't be Quran.
She's Nazi. She's not Laura.
Nasi Quran.
No,
Okay.
I'm sitting with you.
Okay. Okay. Now represent this not A, right? In Boolean notation. A. Please tell me. A bar dot that's all for the Uttara Matagatiana. Nothing else for the exam. Right? Remember, that's all. Then put it into the now write it in expression. Right. Now tell me. Hurry up.
Huh?
Yeah,
X equal A.
not X equal,
no.
you can't come to the X.
No, I didn't say X.
You write it, write this line.
Exactly.
That's
A
not
bar.
Dot B bar dot C bar.
Now come over here. Now run
A bar dot B dot C.
A dot
B dot C.
this one.
A dot B bar dot C bar.
How come C bar?
C bar.
C bar.
So she's X.
C bar. C bar is a dog, right? Now got it? Have we done? Now we have to write the expression, right? This X become on, right? Okay. One of these combination happens. Understood my words? X become on when one of these expressions, combinations happens. One of these. This word, one of these can replace with what? O. Right? Oh, yeah.
I don't do verb.
A bar, B bar, C bar, when you get that, what it becomes one.
Correct.
So like,
Also, O. Right? This is one combination. O. When A bar B C also happens, that become what?
five. One.
What I am saying here is, okay. What I have given here is, right? These are the three inputs, right? Assume that you have brought a device. This device has three inputs. A, B, C. Understood? A, B, C. You don't know what is happening inside. It is a logic circuit. You don't know. But it says there is a alarm. This alarm gets on, right? When this ABC, right, works like this. That is what. Is it clear? Podi gadget එකක් ගේනවා. මේකට inputs තුනක් තියෙනවා. But alarm. What is it? Hi. Ankmita, Nigini, can you hear me well, Pute?
Yes, sir.
Right. You got it? Assume, okay, you are bringing a device, right? One is to measure the temperature, another one is measure something, another one is measure something. These are the inputs. So I am going to plug here and there. I don't know how it is being made inside the circuit, but the output is there. Understood? Right? With your device, catalog. That catalog table that table says, okay, when you do like this, this is working like this. That is what I wrote it here. Understood? So it says This alarm is working when these combinations are happening only. You understand? Right? So what we are trying to do, clear that? What we are trying to do is to understand how this logic circuit been made. Am I clear? Yes. 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 Very yes. Right? So this tells A, B, C. All these three switches switched off. Tunam off. Alarm the alarm is getting on. It tells me, the device tells me, right? You can't relate, right? These are input, this is output, that's all. The middle part, I didn't write. I don't know. Okay? So what I try to understand is how it is working. Right? Understood? The previous one, I had how it is working and I derived to the output. Understood?
So is that why in those equations there are like only two values, like within brackets? It's like it's either A bar dot B and then bracket plus C bar dot A,
Okay.
like that, no?
Hmm.
Then in this there are three, no?
Hmm.
So then is it like you don't know the middle part in this one? Is that why you put like the C in the three in this?
It is not like that always. Okay. Right? Looking at these three inputs, right? Looking at these three inputs, I made a very simple one. Okay. Sometimes, okay, sometimes you may be given like this to answer your question, right? Only to answer your question, right? These are inputs, okay? I don't want to confuse, right? Okay, ප්‍රශ්නෙට උත්තර දෙන්න. Okay, the open switch එකක් නැහැ කියනවා. Now what are the combinations?
A bar
Only B and C. Got it? Okay, so I don't want to make you confused. Got it? You can use switches in any way. Okay? Yeah.
A small question. In the early activity we did, the output was like all were ones except for one was zero. But in the formula, the equation, there were like only two inputs like that. So like, but here like for all the ones there is like equation. So like for that one also for all the ones there to be.
Not necessarily, right? It depends on the combination, right? So what we did is put now from this one, okay? From this one, we straight away deriving this expression, right? Okay. Okay, let me answer, right? Your question is the previous one, there are only like A dot B plus.
No, he's telling now in that one, the x value, there's only 1, 0, but all the other values are 1.
Hmm.
Then, but in the equation they have given only like two bracket sets are there. Like
There are different combinations. Those are different combinations.
So like there is not a rule like for each one there could be a combination.
Not necessarily.
But when
No. Main matter. What simply this tells, right? If you look at the previous example, I used the Boolean expression and I derived the output. That output tells me on which times or on which states of A, B, C that gets 1. This one tells, make it the inputs dila, the outputs are given. From this one, I am going backward. The previous one, what we did? It is from the expression to forward. Okay. This one, I am going backward to construct the expression. So far clear? All right. I will explain, right? After this, I will explain. I will answer your question. I know what is the problem bothering you, right? Okay. Now, each state applies. Each state is valid. Each state is valid. Therefore, that means if this happens, this works. Or if this happens, this works. Okay. Or if this happens, this works. Okay. So then I can write it as X will work when A bar dot B bar dot C is happening. Okay. or
Okay.
A bar dot B dot C is happening, or A dot B bar dot C bar is okay. Dear, right? Up to this point, these are the pictures, right? Arts, not art class. Okay. Okay. Right? What we are learning for your level in O levels is up to this point. But this is not the ending of this Boolean expression. Right? There are further, those are called Boolean expression simplification. Right? Usually those part you are going to learn in either in first year of the degree, kind of that. There are further you can apply, right? There are called something De Morgan theory or something like, there are so many theories. From that, we are going to simplify this. When you simplify, you will get a very simplified small equation that is A bar plus something something square. That is simplification methods. Those are more theories beyond this. Understood? Okay. So up to this point, okay, Natalie?
Yes.
Yes, can you explain now? Yeah, yep. Explain.
The entire
Yeah, yes. So what is the first rule that you have to follow? How to construct, right? The expression. Yes,
you're like fine.
no support.
No,
I-
he didn't do anything.
No, I didn't tell.
And-
You don't worry,
I didn't
you don't
do
worry about. You don't worry about.
That's something you want to do is find out the one value.
Find out
The one value.
of
X.
X mean
The output.
output. Okay,
And then.
okay, okay.
And then you're like, like, write like a.
Put it in words. Yeah. Yeah, yeah, yeah.
So I know how to, I don't know how to say.
Okay. Doesn't matter. Okay. Somehow tell me. Put the bottle down.
Then,
Okay.
yeah, and then.
Aviana? Okay. Explain now. Battle is given to you. From that point, you continue. Yes. Come on, come on, come on.
What is it?
I'm not supposed to. You have listened.
No, what was the last? What was it?
What happened? I got stuck over there. Arpita, Nikini, can you hear me?
Yes, sir.
Great. You can see me? Nikini, Arpita, can you hear me, right?
Yes,
sir.
Okay, great. Okay.
Like-
Yes. Avian.
How's that?
No, she stopped somewhere.
Wait, what is it?
just stand on the beginning.
It's your.
Just stand on the beginning.
What is the name?
She didn't
Come on, come on. Hurry up. I want to go into the new lesson today.
There's a new lesson?
Yeah.
No.
Hurry up, hurry up, hurry up. Jason. You can. You can.
But
Doesn't matter, you start from the beginning also, doesn't matter, you can tell me. At least now listen everyone, right? Don't do anything else. Right? Okay, Deshara? Yes? Okay,
You must find the output for one term.
okay.
From the input A, B, C,
Yes.
like if there is A is equal to C and B is equal to C and then A bar dot B bar, then dot C bar, then of R, and then do the same for the other value to have one term. Then construct the equation X equal, I took over there. A bar dot B bar dot C bar and put brackets and
Okay, okay, put it to straight.
on the middle, put
Why you make it addition?
all together.
Correct, correct. All together, right? Each combination makes the X one. That is why. At least one makes the result, right? Very good. We may out of the words. Right. Right. Ahangindone. Right?
we go
Okay.
there. Yes.
Right. My eyes are running around. I can see, right? So don't do anything. I'm asking questions. Huh? Definitely.
Third chakra. Chakra.
I have. Yes. Yes.
Sir, I have a paper.
So that means in future you will get eye from there.
Yes, sir.
But make sure not to home, nah?
Dear gets the most eyes.
Okay.
Dear gets the most eyes.
Okay. Understood now? Okay. Right. This is the whole story of it. Boolean. Right. This is the whole story of Boolean. Right?
That.
Arpita, any questions from you? Nikini?
No, sir.
Okay.
I can see better than you. I'm jealous.
So this time everyone has to score, right? Natalie?
Yes.
What?
I have to score.
Huh? Right. Okay. The final one is what we have learned, the application of Boolean expression, right? Application. So we know what it is. The application is now you get a real example. Okay. You get a real example. Now let's understand this. The same example which I have been practiced. That is wind turbine. Wind turbine, right? Wind turbine, right? As a bearing, right? It's bearing getting hot when it is, right? Revolving very fast. This is now a story. Revolving very fast. Therefore, right? If it goes beyond, if it makes too hot, that it like your vehicles, you have heat indicator, right? If that goes beyond, what is happening? The car getting stuck, heated, and getting stuck. Oh, the car get damaged, right? Overheating. So, right?
Pleasure. Pleasure.
Right. So, if the heat is reaching about greater than 80, right? Heat is greater than 80, right? What it says is, right? If heat is greater than 80, like this sensor sense getting on. Understand? Sensor getting on. And the other one is if wind velocity, what is velocity? Speed. Right?
Speediness is with direction. No, velocity is a vector. Speed is a scalar.
Above 100 kilometers per hour, very high speed, the sensor, right, should get, right? Okay. And also it says, when the velocity is less than 40 kilometers per hour, right? Sensor getting, let's say, you're getting confused there, right?
Yes, sir.
Thanks. Let's make this as A and this as B. These are two inputs, right? These are two inputs. So we can construct a Boolean expression, right? It's a very simple one, right? Not a complicated one. The alarm should on. The alarm should on. Alarm on when, right? Heat become greater than 80 centimeters. Alarm should on. The other one is
Reverse start.
what?
Reverse start. In virtual life. In virtual.
Bikini, can you hear me?
Sir.
Yes, sir.
You can see the board, right?
Yes, sir.
Right, right. Done? Understand this, okay? So the next one is alarm should on when the wind velocity goes beyond the velocity, right? Goes beyond 100 km/h. Now understood? Right?
Yes, sir.
So you can denote this with A and B. A and B are the input. Okay. So A getting on, right? It says, now but how this alarm should on? Right? Alarm, the person who is looking after this, he is telling me this alarm should on, right? Either one exceed the threshold. Am I clear? දෙකෙන් එකක් වෙනවා නම් alarm එක on වෙන්න ඕනේ. Either one exceeding the threshold. Am I right? If the heat, right? Alarm on, right? When either A or B exceed the threshold. Can you read my handwriting?
Yes, sir. You have been trained in that way.
Now for mentors.
I have been trained for 13 years.
I've seen the
I'm,
doctor.
I'm very bad. I'm very bad on writing, right?
Sir, right, right.
Yeah? Yeah?
I'm like that.
What is that?
No, your handwriting can read. No?
Really?
What is your concept? So you were a doctor.
What? Who?
What is your concept? So that means you were a doctor.
Thank you.
No, they're-
Luckily not treating anyone.
no, so the handwriting.
Handwriting. Okay. Handwriting. Right? Like Kurutu Gita, right? In Sigiriya?
Yes.
Have seen?
sir.
Yeah?
I've never been to see.
Great.
That's with the
Very
alarm
good.
on when alarm on
Okay.
alarm on when either A or B exceeds the threshold.
Yeah, the police, it exists.
Okay. You are scared for that.
Yes, I'm scared of heights.
Sir, try,
Aiyo.
sir, try
You are
writing.
scared of heights. But you are climbing.
It's like this. How are we supposed to climb like this?
Huh?
I'm not Tarzan.
Right. Now the alarm, if alarm says X, right? And if A represent, A is getting on when the heat is over 80 degrees. A is always make it plus, right? That means this is a very simple example I took, right? When A or B happens. Right? It's a very simple equation I explained. Using, right? But question paper is not like this. Understood? Right? So I believe last I gave you 4 or 5 questions similar to this.
Two.
Not 2. Not 2.
Yes.
Right? There were 4 questions, I think. Am I right? Done, everyone.
Only two.
So far clear? Okay? Brush. Done.
Yeah.
I gave 4 questions. I gave
Last
part.
Last part.
So all questions have to be done, right? I need.
Yes.
Okay, done. Okay. So you have to draw the truth table. You have to design the logic gate. And if time permits, right? I will give you to design a logic gate and make it using a breadboard and components. Huh? You construct the circuit, make the circuit, right?
The body is something like it's like
I had some ICs and kind of things, right? If time permits, then only you will really learn, right? It is really interesting.
There's only time.
Yeah.
Only the things you may have to buy it. It is not that much expensive, right? Okay. Okay, right? I will do one here, then after that, you will do it. Okay. So far clear? Right? Let's switch on to the next lesson. Right? So this lesson is clear, right?
Yes, sir.
And remember, this is the easiest lesson. Okay.
Ever.
Finally, everything is easy, right?
That means the object is in front of the focus.
Oh my god.
That you have a yes, the word. Let's see whether focal point is of this.
Can I know what I know? You don't. You want to give it to. This tell me how you are talking about it. Now somehow on Monday I want to. Whatever after all.
Oh no.
You are not telling me. Not me. Not something. Who is that?
Genius that. Again, look for the part two.
Let's show them.
You
Let's show them. And
Yes.
he's going to.
said that.
That was as the fan. The fan.
Okay.
Show them.
Fan.
We are going to
Where's the fans?
you guys need to.
You are leading a man. Ah,
The fans.
yeah. When see this.
The fans are- How does it? Things like this fence is not.
It doesn't know about. Fancy these things become other person. Right? Yes, AC. Fancy these things. AC. Fancy this. That's not good. But you know, they don't use it anymore. You can't say it now. They don't want to.
How are you going to? Spanish.
Ah. Very complex situation. I don't use it.
What's
I
the
got
right
it fans
way?
number.
No, you learn to feel that like in this lens, it becomes upside down. Yeah, it does. If this.
It is not AC. What is
This
it?
is
Objection of delegate is not.
I don't know that flows.
The get of you, let's say.
I am looking through those.
Same thing, I can't see idiot.
No, I think
And that flows.
Who is the idiot?
Okay, you can remove it, remove the glass. Yes.
Wait, both,
Huh?
it's still the same.
Because you are wearing glasses, remove it.
Keep
The blind, you see the zero one.
No, not that close. Not that
Oh, it's upside down.
You are blind.
Yeah, call me Dora.
It's good having it. I had good valuable asset.
But it's
But you have magic camera.
that yes.
Yeah.
In my life.
Okay.
And see,
Oh,
it's not cats.
you have a nice camera. I have a nice camera.
You made it that way, bro. I feel like I actually have something about cats.
Complex. Let's get.
Right, let's get into the data transmission.
Serious something. What we are making possible like.
Data transmission, right?
After 1 minute.
So far we have learned about data. That is, we learn about binary. So data being transferred using in the format of binary, ones and zeros. Okay, dear? Yes? Right? In the binary format. Why we are transferring data, or why we are using binary format for the data transmission?
So the computer can understand.
Huh?
So the computer.
Why the computer can understand that?
The computer is made up of millions of switches, and the switches work in on off state. One represents 0, off represents 1. And you got that?
Computer can only understand how to do. What I know. But 2020.
Oh,
Yes? Can you answer my question?
Yes.
I don't know why my eye is bothering that much. Always my eye is catching it.
what?
Huh?
This
Huh?
also the same.
Not? Who?
Not them.
Not task level.
Huh?
I mean, I and diagram in the decline.
Huh?
Not task level.
Okay. Why binary is being used for the data transmission? That is my question, of course. The computer can understand in a way that the computer can understand only in ones and zeros, not ones and zeros. It is on and off, because it is electricity flowing through the computer system. So that is the only thing that we can use, right? So without making the story long, data transmission. Okay. Now all these binaries been learned for the purpose of data storage, storing, and communication. Communicating. Right? Communication mean I should be able to, right, communicate or send data from one point to another end. Okay, one point to another end. So in this data transmission, we are discussing under three areas, right? One is types and methods of data transmission. That means how we can transfer data, right? Second part is method of error detection. Okay. I can send data, but how am I make sure the sent data are exactly received to the other end? You get it? Received to the other end. Error correction, right? It has to be 100% error correction. Okay. So the thirdly, the encryption. Encryption means security. How to make sure that it is well secure, right? So there are three things. One is how should I send data? Secondly, right, whether how I'm going to make sure that it's been received perfectly. Thirdly, how I'm going to make sure that it is secured. Well, clear? Right. Let me take this. Okay. Amna wrote or send a letter to a friend or family. Yeah. Posted. By post. Huh? How many of you wrote? Yes. Anyone? Natalie? Yes? No? Yes. Huh? Right. So you can remember how you wrote a letter and posted it, right? Not electronic. I'm asking not elect. You wrote piece of paper, you put it into the envelope. Okay, envelope. Then you close the envelope. Then, okay. Now recall that memory, the wonderful, beautiful memory, right? Yeah. So this looks like an envelope. The front side of the envelope. That is back side. Okay. So now this is the envelope. Okay. Inside the envelope, what is there? The letter. Right? So your paper is you put it inside. You put it inside. Yes, today. Yes, yes.
Paper in a paper.
Paper in a?
Paper.
Okay, good question. Good question. Paper in a paper, right? The first paper means what?
To make sure that the data
I'm
inside.
asking for.
Answer.
Erase the question.
Answer means
Paper in a paper. What is the so can you define the first paper is what?
It holds the information.
What is the second paper?
It keeps it's
has paper.
no.
No.
It keeps
It keeps it safe,
It keeps it
like secure.
material is same. Right? Material is same. But the same material represent differently with its purpose. Right? Yeah. You raised the question unintentionally, but it has a meaning. Right? The material is same, but material matters the way how it represents. You understand? In general, you can call me a human. Understood? But at this moment, that human named as teacher. Teacher. Right? But at home, I'm father for him. In the office, the same material represent differently with its purpose. Okay? Did I answer your question? Yes? Happy?
Yeah.
Right, good. Right. So, this paper contains information. You put it inside, right? What is this? Is an envelope. See, even though it is a paper, right? We name it different. It is called an envelope. When you say envelope, right? What that creates in your mind? Something enclosed. Something enclosed. Am I clear? What is the thing that comes into our mind is you put the letter inside, you cover it, you make sure that is pasted, nobody can open it. You understand? Right? That is security. Right? That is why I took this exam. What are the three areas? Method of sending data. Second one is make sure the error are not there. Thirdly, encryption. Security. Right? That is why I'm taking this differently, right? Through this I'm explaining. So you can understand it better. Right. Now the letter is inside, you paste it, everything covered perfect. Now this is a kind of a packet. Am I right? Small packet. Right? So we don't send numbers in the envelope. You understand? Small piece of a part of information. Am I clear? Right. Now tell me, right? You put the information into the envelope. Now you have the envelope. On the face of the envelope, right? What you do? What do you do? Huh? Is that first we do? Put it in order. Yeah? Address it to someone. In other words, it is called recipient address. Recipient address. Right? Where do we usually write recipient address? Left or right?
On the left.
Left or right?
Right, sir.
Left or right?
Left. L for left. Left.
Which side? This side is left?
No, sir.
Then?
Yes, then it's right, sir.
Okay.
I don't know what is
Right?
no problem.
This is left, this is right. Which side are we writing the recipient address?
Right or left, one of them.
ROL.
I told you in the new lesson.
Recipient address. Got it? Recipient address. Are we going to change this? For any reason, are we going to change this?
What if they
No.
play?
What will happen if I change it?
It will go to a different house.
Okay, recipient address. What you are writing on the left side?
Our
Our
return address.
Senders.
Address.
Senders.
Address.
Very good. ලියුම් ලියලා තියෙනවා නේ දේශාක? නේ? හා? එහෙනම් මට ලියුමක් ලියන්න ඕනේ. Writing a letter. To me. Okay. Right. On the left hand side, sender's address is there. On the right hand side, recipient address. Right? Have that ever been changed? No. What will happen if that change? You will receive your letter to you again. Not receive, it will come to you. You understand? Okay. Right. Now, recipient is there, sender is there, right? Now imagine you are sending a letter and now I am making it little different. This letter is very important. Very important. If it is an important letter, what is the method that you follow here? Additionally.
What?
If it is important, right? Name හිතන්න. ඒක important නම් ඔයා මොකක්ද බලන්නේ?
Formal.
Say, for example,
Make it formal.
you have a letter that you're supposed to send it to me. Very important. What is the top of mind targeting? මොකක්ද දෙන්නේ?
You check who sent it.
Simple විදිහට හිතන්න.
Check who sent it to you.
Huh?
Informal.
නෑ නෑ නෑ.
You check who sent
No, no, no.
No, it should be.
No, no, no. Huh?
Huh?
My question is,
Can you give me?
my question is, right? You are sending a very important letter to me. Right? මොකක්ද ඔළුවට එන දේ? What is the thing that comes into your
Make it creative.
everything? No, content. I'm referring content and everything done. I'm not referring.
Make it that it will come to you.
Yes.
Wow. Oh my God.
You have to make sure that I receive that.
I said,
Understood? Otherwise, what will happen?
I never.
You are so curious whether it has gone to me or someone has taken it. You understand? You are writing some, okay? So Natalie is writing a very secret thing to me, right? So I should not expose it.
Yes.
You are very,
And the last.
hamburger. Okay. Got it? So what will happen? Now she's very curious. What will happen if that letter goes to someone else? How to make sure that? Now understood? Okay. In this general post, even today we are doing this, right? How are we going to make sure that exact recipient accepted and got it? My words are very important, right? Accepted and got it.
For example, in WhatsApp,
WhatsApp is, huh? There is no point of sending the letter back again, but your thought has some clue there.
We tell it to RSVP. We tell it to reply.
So put the recipient address on the letter also.
Yeah, you put in the recipient address. Additionally, we are doing something else. Huh? Anyway, we have to pay for the
We
stamp.
ask for signature.
Unfortunately, I believe you all have not come across that. Okay. What we do if it is an important document we are sending, we send it through a registered post.
Just gonna
Have
say
you
that.
come across?
No.
Seriously?
I was gonna say that.
Huh? You should go to the post office. Right? Registered post mean, listen, registered post mean, okay? At least go to the post office, look at how it is happening. Registered post mean, if it is an important document, I am going to the counter, post office, and I'm telling I need to send this through a registered post. Then what the person doing there is, he is writing the sender recipient in a book, right? And issuing me a separate document. Okay? When this letter goes to the other post office, that person comes to your house and he never hand over this letter if the exact owner is not there. How to make sure? He's asking the signature of acceptance. ඒ කියන්නේ ලියුම් කාර්යයන පොඩි කොලයක්. Sign here. අස්සම් කරලා ගන්න ඕනේ. That makes sure that is received. So I can
But-
anytime go to my post
But
office and ask,
Anyone, is it anyone's signature? Or how do they know whether it's their signature?
they are checking. Who is this? Is this person there? Right? But not exactly, but it goes to the house. අපේ ගෙදරට ආවනම් මම නම ලියලා අස්සම් කරලා ගන්න. The signature is there. Right? That is a legal document. See? Really? Now you are wondering how the registered post sending a letter? Right? Okay.
So they know that it's.
Right? Now what is happening?
Even the
Okay, if you pass through a registered post, they paste a number here. This is a tracking number. If this letter lost, I can track. And if the recipient is not there on the other side, this letter comes back to me, saying that there was no person to accept it. That is called registered. Now understood?
Can say you have reset the thing again, or it's make you returning back?
I can reset means that I can check whether this address is wrong or what has happened. Usually they mention, if the address is correct and if there's no person at home to accept, I'll tell you no. That is why it is written. Nikan dala inne. If it is a normal post, what they do? If they even though කවුරුවත් හිටියන්නේ නැත තාප්පේ මුල් ගේට් එකෙන් එළියට කිසි කරලා එනවා.
I mean,
Right.
like,
Right.
same how
Got it?
you just have to go to the house. That's why I asked my father whether how they know the exactly.
Yes, extra.
So it's a,
How
it's
it's
no one
like,
can,
whether
you have to pay again, then they can do.
No. For the registered post, of course we pay additional. So if there's no one, it comes back to you.
But then you have to send, if you want to send it again,
Again, it is a new. You
You have to
cannot
pay-
send it. You have to put it again, open it, put it in the new envelope. Again, you have to resend it.
pay again and resend.
Pay again and send it. Now understood the mechanism? Yes? Right. Okay. So what is here is, right? This is a packet, right? This packet contains, right? Now I am relating this to data transfer, right? Now carefully understand, okay? Don't start crying, right? I'm going to run out, right? No, she's going to start crying. Okay. This is called, what is inside there? What is inside there?
Data.
Data. And you put it into this is a packet. So this is called a data. Data packet. Understood? Understood? When you send in this, right? You pay for that. Right? You pay for that load. If you are supposed to send a parcel, what do? You go to the post office. Even when you send in this letter, right? Put it to the registered port. What they do is first, what they do is they first wait.
Even envelopes, like when there's 0.1 gas.
Document is wait.
I once you go taking away,
Huh?
you go take
ඒ wait එකට අනුව stamp fee එක වැඩි.
They don't know whether there's
And the
any.
stamp fee is charged. They measure it. Wait. Understood? Understand this? Right? What is now? It represent the weight of what? Weight of what? Huh?
the amount of.
It is the load you are waiting, right? What is inside is what is loaded inside the envelope? Am I right? Yes?
So then how do they remove the envelopes? Wait.
No?
If
You
it-
don't remove.
So if you said it's the.
Now when you go to the boutique and you buy a banana, is that person selling you without the peel?
I mean, they put it in a bag.
Huh?
They put it in a bag.
You have to pay for the peel as well.
Useless.
Huh?
What?
What is this? Huh? Okay.
Drama.
Okay, listen, come on. Right, this is been weight, that been weight, come on. Right, there is a, okay, there is a load inside, load. Right? බරක් තියෙනවා මේ බර කියන එකට අපි load එකක් දාලා තියෙනවා. Load. Right? For this load you have to pay for the post office. Okay? Okay? ඒත් අපි මේකට කියනවා payload. For this load you have to pay payload. Understood? Understood? Yes, payload. Okay? So for the data inside is what you call payload. Understood? And remember, and it has a recipient address, it has a sender address. Is it clear now? Very clear? Right. Now let's get into this. Look at this diagram, how this data transfer. Right. Can everyone see this?
Question 95 ones.
Right. Okay. Right. Can everyone see this? Now, this is a one piece of like envelope. Okay. So this is like an envelope. Now this is how the data is going on. In this piece of data, this is called a data packet. Okay. Through this network, when you are surfing on the internet, when you are using this mobile phone, right? How you see everything, right? When you send request over the browser, things coming in this format. Okay. So the middle part is called payload. This is what I explained so far. Right? This is called payload. What is this payload? Is the actual data. It is the content inside the SARA. Okay. Okay. Yes.
The actual thing inside the
Right. Actual things inside the envelope. Data. Okay. That is called payload. Usually this payload data packet is somewhere around 64 kilobyte size. Small. Okay. And there are two parts, that is header and the trailer. Okay. Header and trailer. This header contains, right, IP address of the source device. That is sender. Like on envelope, the sender's address. Okay. If you are sending a request, if you are sending a, say, for example, email to someone. So your email address is in the header part of this. Okay. Then IP address of the destination device. That is the recipient address in the header part. And the sequence number of the packet. Okay. I will explain what is the sequence number, right? Email is something like a lengthy. It is broken into small pieces, right? You cannot send, when you click send email, it doesn't mean your entire email, click of a button, right? Travel to the other side. No, it is been broken into 64 kilobytes, small data packets. Each packet is sent. That is how it is traveling across the network, internet, right? The sequence number is you have to number each and every piece. Okay. Then the size of the packet in bytes. Okay. When you're breaking into pieces, like you take a loaf of bread, you slice it, the size of the each slice, right? The last slice weight may be different than the other slice. Okay. The middle part is the actual data. Then the method of identifying the end of the packet. Now it make choti calculate karna. This is keep on going. There is a mechanism. They should understand, okay, this is the last part of the data. Otherwise, this is keep on going and it doesn't understand what is it. Understood? And some from error checking to ensure packet arrives error free. Okay. Let's look at the board. Okay. What's going on? My eyes are very bad. Huh? Because I have two eyes. Where is spectacles? Huh? Assume that this is a, okay, this is a data length of image. Okay, image. Got it? You should be able to remember, we worked out the size of the image when we are learning data. Can remember? Only no measure
It is.
What we do is, now I need to send this file across the internet. What I do is, I am breaking it into 64 kilobyte small pieces. Last part may be the small. Okay? Don't pay attention. Now what do you do? I pull it out. This is how the computer network data packet works, okay? And what is this? This is the image. මේ තමයි ඔන්න අවියාන ඔයාගේ ෆොටෝ එක යවනවා වාගේ යාළුවට. Understood well? No.
I said it.
Yeah, correct. You are sending your photo to your friend, right? Now, over the internet, what is happening? They make us chuti calculator small pieces, put it into small pieces. Right? Now Aviana broken into, right? Cut and chopped into small pieces. Right? When it is cut and chopped into small pieces, first of all, what it does is it numbered 1, 2, 3, 4, 5, 6, 7, 8. Right? Look at the board and understand. Okay. Okay. Don't miss it. Okay. Now, my computer starts, not my one, Raviana's computer starts sending this image, right? So what it does is, it is broken pieces. It starts sending. Got it? It pulls out the first one. Right? Now this data. Right? What is over here? The piece of your image. It is called data. And what it calls? Pay. Understood? Now only this cannot travel across the network. It has to have some more things to add it. Recipient address. Recipient address. Sender's address. Sender's address. Don't understand it like a theory. Assume that, right? How you are going to send your letter to a person.
That payload is only for the number one.
You're correct. It is only for the number one.
Why can't we send it all together? Like everything together?
Why? Good question. Right? Okay. Now, let me ask a question like this. To your house, right? How you get water? Through what? Pipe. What is the size of a pipe? Small. Right? Now, your question is, the water tank is there. Why can't you put all the water through that pipe? So that is why water little by little coming through that pipe. Now understood? Otherwise, you can bring the tank and put it down and have a bucket near and have a good bath. Without have a pipe. Now understood? That's the joke. Okay?
Sir, but water is coming continuously and the data is split to packets.
Repeat for that.
Water is coming continuously, but the data is split into 1, 2, 3, 4 packets.
Yes, Pude. The water is coming like data also continuously through a network tunnel. But that data is different, right? It can be anything. It is like water flowing through, right? Okay.
Okay, sir.
Got it? Now you should have a right recipient address. Understand this very well, right? Send the address. That's done. You don't know to whom you should send it. Understood? Okay. My eye is always catching you. Look at the board. Okay. Right? Huh?
It is so invisible.
Right. Now the
Sir, Jehana is so invisible.
right.
Why not, sir?
Okay. Now you are sending this packet. What tells this should indicate? Should have. Come on, quickly tell me, Deshara.
what it is about.
Right? You're teaching her. You're teaching her.
A sequence.
Today I'm very naughty, yeah. Right. Okay. What should this? Now this is your payload data.
Sequence number.
Yeah.
Sequence number.
The sequence number. This has to be written over here. Understood? Okay. This has to be here. And this should have the last number as well. You got it? Now we have this. This is called the header. Header part of the
Sir,
data packet. Yes.
in that one, in the header, size of the packet.
Yes. One more thing, right? Size of the packet, right? This may be 64 kilobytes, 64, 63, 60, right? 64, right? 50, 64. This may be 14 kilobytes. You understand? If you add all together, you will get the size of the actual image. Actual image. Got it? So this is being written here. It is 64 kilobytes. Am I clear? That is there. Now the latter part is the trailer is method of identifying the end of the packet. There should be a method to identify the end of the packet. There are methods which you are going to learn. For the time being, I will explain what is the simple method that you can have here by looking
Find the
at this.
sequence number.
Huh?
The sequence number.
What sequence?
Like
No,
when it is
what-
8.
What is the purpose of this? Finding the method of the end of the packet. In the trailer, end of the packet. Packet is, right? You put it in the packet, end of the packet. And there should be a mechanism to find the end of the packet, right? Let's understand later how to calculate this. The next one is some form of error checking to ensure packet arrives correctly, right? Error checking. Both of you. Okay. Right? Error checking. Got it? Right. Simple method I will explain. Just to understand. This is the data packet. 1101011101. Can you tell me a simple method to if this is being sent to the other side to check the error?
You tell the
A
other,
simple method.
you tell the other person whether he got the exact same thing.
How you are going to tell?
We send it, we tell it to them.
You can't tell. This is going through the network. Then make a network. There should be an algorithm. That you have to think like that. Algorithm.
You cannot, you check whether it's the same dealer.
Don't think loud. Simple.
Let's say, send
You count how many ones? 1, 2, 3, 4, 5, 6. You can tell there are 6 ones. And 1, 2, 3, 3 zeros. Are there 6 ones and 3 zeros? But that is not perfect. That is not perfect. Understood? Why not perfect? Why not perfect? You are correct. You are correct. Right? When this is reaching to the other end, right? This one can be 0 and this 0 can be 1. Still number of ones are correct, but data incorrect. You understand?
that.
Right?
Thank you, summarizing.
Okay. Right? There is an algorithm to do that. Now algorithms are like mathematically. Now there is error checking. Now is it clear? Right. This is called, this is the trailer. Okay, this is the trailer. Right?
Yes, what is the
So far clear? Okay. For each and every 1, 2, 3, 4, each and every data packet runs through the network like this. Okay. Right. Then, say for example, this is your computer. You are connected through the router to the internet. Okay. Internet is, right, so many computers connected. And finally, you come to the recipient machine. Right? You ask why we are breaking this. Isn't it dear? Right? වතුර ටැංකියම ගේනවද? වාදිය. Right. වතුර ටැංකියම ගේන්න කිව්වොත් අමාරුයි. Right? When you break it, advantage is it becomes fast because the file size is small. Got it? Secondly, you break it, you can send everything to the network. You got it? Your whole file is broken into pieces like this, right? 1 goes this direction, 2 goes this direction, 3 goes another direction. Like you can send packets, release the packets to them. So it runs, that means it checks which path has less traffic, it runs there. The next one comes, it checks which path has less traffic, it runs there. And finally, every packet comes over here. Right? One may be, right? Sometimes one came late, right? Fifth came 6, 4, 3, 2, like this. It has been arrived to the destination computer. And what it does? It will rearrange and construct the image on the other side. That is how it is happening. 1, 2, 3, 4 code and checking errors. Understood? Right? That is why it is breaking into small pieces. And so first one is you break it into small pieces that become fast. Number 2, right? Each piece can travel in different channels at the same time. That makes much fast. Number 3, when you construct this image on the other side, if one piece 4 is not in proper order, he has to send only 4 back. You understand? Then it sends 4, return that to the sender. That is why the sender address is there. Telling that 4 is incorrect. Then it travels back. Then the sender computer sends the 4, data packet number 4, again back to the sender. That is how the data is transferred. So far clear? Right. See, okay, this example, right? Over here, the 1, 2, 3, 4, 5 different color data packets are there. Okay. Right. Computer A has the image. It is broken in 1, 2, 3, 4, 5 data packets. Okay. And the computer A sends through a router. Routing means right? Searching for routing. Routing means you are sending to different directions. It is not searching, okay? Routing. You are sending through the less traffic directions. Now you can see how data packets are traveling. This is how. And finally, it reaches to the router. B is the recipient. Yeah.
When it's going like that, like it's in the same image, no? Like all those 5 data. Then how
Not same image.
Right.
Piece of image.
Yeah.
Piece of the original image.
Yeah, but like how does it know when it's going like that? Or like other data is also going like,
Other data mean?
like other data, you know?
Other data
Yeah,
mean?
Anita gave.
All those are packets. Data packets.
Yeah, but like how does it know it belongs to the same image each one?
I didn't get you. Mokada kiwi again?
No,
Like that whole image
Yeah.
is broken into small parts.
Okay.
Like the each of the parts are going in different directions.
Correct.
Then how does the router B know that that each part belongs to the same image?
Because an
Router B. The last B.
Because other ones are also there. Those data.
Others data.
Yeah.
So it is always has, right? The sender, recipient, image ID, right? And image size, right? Image identities are there. You got it? Okay. Yes? Okay. Right? So my questions. Right? What is payload? Actual? Okay. What is the size of, what is the normal minimum size of the payload? Yeah. 60? 64?
Kilobytes. Kilobytes.
Kilobytes.
Kilobytes.
64 kilobytes. Right? 64 kilobytes. Right? When you get a data packet, what are the 3 parts of the data packet? Yes, Jana. Yeah, you're right. Header, payload. What is the last part? Right? What contains in the header?
address,
IP address of the sender.
Correct. IP address of the sender. Correct.
IP address of the receiver
Recipient.
and the sequence number,
the number of
size of the.
number,
Akmita, Nikini,
size of packet.
I like to hear your voices.
Yes, we can't hear you.
The sequence number of the packet.
Size of.
The size of the packet.
In bytes.
In the trailer,
Trailer,
method of identifying the
and the source of checking errors.
source of error check. Method of identifying the end of the packet. අන්තිම එක මොකක්ද කියලා හොයාගන්නත් පුළුවන්. Otherwise, it will keep on going and it don't finish the job. Why? It doesn't understand or it is waiting till what is the last file. Got it? Then the sum of a method, error checking method. Right? So far clear? Why this is broken into small pieces?
More efficient, more faster.
More faster,
Fast.
more
Efficient.
low weight, right? And yes, less data is consumed through the internet tunnel. Got it? Even with less bandwidth, you can send data. So far clear? Any questions? Nikini, Akmita?
No, sir.
Then no question, let's wind up the class. Okay? End of transmission. Good, enough? No? Now, please, everyone, Nikini, Akmita, how I can get your homework books? Can you send it through Shankar?
Okay.
Right.
Okay, sir.
Okay. Others, please keep your books here. Okay, then let's wind up the class today. God bless you all. Good day.
God bless you, sir.
God bless you, sir.